Hi, I'm Irina. Today I will be presenting my major equipment, which is a dry methane reactor furnace R801.
This presentation is divided into 5 main content. The first content is the introduction to furnace, followed by the design methodology, sample calculation, furnace specification sheet, and lastly its technical drawing. So let's proceed with the first content, introduction to furnace. So what is furnace? Furnace is also known as a direct fired heater, is an equipment that produces and provides the required heat to a process. This figure shows a typical type of furnace. A furnace consists of a few components or sections. From the bottom, the first component is the burner, followed by radiant section, bridge wall section, convection section, and lastly, the flue gas tank. There are a few types of furnace available, such as vertical cylindrical, horizontal tube cabin, hoop tube, vertical tube box, horizontal tube box, multiple cell, and also helicoil. The furnace is differentiated by its duty. For my equipment, I have chosen the vertical cylindrical as it has the duty of 150 MBTU per hour. This is suitable because the duty obtained from Icon is only 104 MBTU per hour. The next section is the design methodology section. To design a furnace, we start with the selection of the type of furnace. Then we do the heat balance. These are followed by the radiant section estimation, the furnace mechanical design, the cost of equipment, and lastly, its technical drawing. The third content of this presentation is the sample calculation in designing a furnace. These are the few things that were calculated for designing a furnace. Heat liberated by fuel are calculated by dividing the heat duty with the target efficiency. Based on the guideline by KLM Group, heat in the radiant section is 70% of the total heat and the spacing between tube is 2 times the nominal tube size. The exposed tube length is obtained by dividing the surface area with outer pipe diameter, and when this value is divided by the individual tube length, we obtain the number of tube required in radiant section. By taking into consideration the number of tube and tube spacing, we will obtain the radiant section diameter. So now, we proceed to the next section, the specification sheet. In the specification sheet, we have the process condition, the fuel and air characteristic, and also the radiant section details. Now, we will continue to the last section, which is the technical drawing. The top left drawing is the radiant cross section, where the diameter of the radiant section is 8.85 meter and the tube has a diameter and the individual tube has a diameter of 0.168 meter. Top right and bottom left picture is the plan view and side view of the furnace respectively. And the last picture is the inner and outer diameter of the individual tube. So that is all from me. Thank you.